Hey, I'm going to start to talk a little bit about the moment R and the rotation, the direction of the rotation for the moment. One of the problem that may become confusing at the time that we start to work with the moment is that uh, what's the distance and what's the rotation direction. Remember, if I've said that in a very simple form, that if I have a point O and then I have a force, the moment that force creates about point O is the force itself times the normal distance, which is d. But always it might not be very easy to find these two. So I'm gonna just put up some examples, show how it's gonna work. First of all, for example, with start anytime that you have, and if you have the point O and you have a force, the first thing that you need to do that when you want to find the direction of when you want to find the normal force, normal distance, is that extend the line of action. Just draw the line of action. So that's the very first step you're going to do. Draw the line of action of the force. And then from that point, draw a line which is perpendicular to the line of action. It's always perpendicular to the line of action. This is going to be the D. So that's the F, that's the D. Always do that like that. Another example. So assume I have point O here, and then there is a force like this here, and I want to find the normal forces, the moment. So I'm gonna extend the line of action, and then from that line of action, from the point, draw the line that is perpendicular to the line of action, and that's your distance. About the rotation, it's which direction is going to rotate. Anytime that you have the forces like that, then it's at the point O and there's the forces. Anytime that you want to know which is it rotate clockwise or counterclockwise, eventually you will get used to that and you don't need to do that, but initially it's good to that assume there's a rope connect from point O to the end of the force, and look at which direction this, and assume this point is, this end of the rope is stay there, it doesn't move, and that end of the rope can move. Now if I move that rope, is it going this way or that way? If it's going this way, so it's going to rotate clockwise. If it's going the other way, it's counterclockwise. So for example, for another example, assume I have a rope here, and then I have that force here, so I want to see which direction is going to rotate it. So I'm going to again assume there's a rope connected from here to the end of the rope, and I said, okay, now if this end doesn't move and that end can move, and I apply these forces, which direction is going to rotate, and so this is going to come this way, so it's going to be so it's going to be counterclockwise. That's how we are going to work on it. So I'm going to put some simple example and show how we can do this calculation. Before that, if you're doing the 2D calculation, I suggest that before start do any calculation, the very first thing I suggest you to do is that find the component of the force along the x and y direction, and then start do these things. It's going to be much easier to do the calculation along the x and y direction rather than doing it in some given angle. So that's my suggestion, but still you can do it any other way. So let's look at some example and see how we'll do that. So it's a simple example. First I will start with something like that. If I have it here and I have a force sitting like that, I want to find its moment. Again, I need to find the normal distance. What was the first step? Draw the line of action. I draw the line of action, and the line of action goes through the point. If the line of action goes through the point, there's no moment. It's zero, because there's no distance between the point and the line of action. The distance is the distance to the line of, draw the line of action, it goes through the point, so there is no moment here because the distance is zero. Now assume the same thing, but assume I have the force here and the point O is sitting here. I want to find the distance, so I go there again, draw the line of action, and from the line of action draw the line that is perpendicular to the line of action. So it's perpendicular to the line of action. This is going to be D. Which direction is going to rotate it? Assume there is a cord connected from here to the end of the force, and it's going to rotate it like that. So when I say it's going to rotate like that, so it's going to be counterclockwise. That we have. Now assume I have another example here, the same thing, but this time I have a force applying with this format. So this is the force with the angle applied here, and this is the point O. Again, I said in the 2D the easiest way is that go first and find the x and y component. So the x component is this, the y component is this. So I calculate this. If this is the f, so this is the fx, and this is the fy. If that one is the f, which is the f. Now I will find the moment for each of them and add them together. So instead of finding the moment for the f, I find the moment for the fx, then I find the moment for fy, and then I would add them together. So I start with the fx. Again, draw the line of action for the fx, and then draw the line that goes from the point perpendicular to the line of action. So that's the D. So the moment here for the fx is, so the moment here, the sigma m, so is the fx, and assume that times D. And is it clockwise or counterclockwise? Again, you look at that. If I connect the rope from here to the end of the force and see which direction it's going to take that force, so it's going to take it like it's a counterclockwise, so it's going to be positive here. The second force, when I want to do for the fy, to calculate the moment for the fy, is just that I have to find the line of action again. If I find the line of action for the fy, it goes through the point. It's going to be similar to that. The line of action goes through the point, and because it goes through the point, the distance is zero, so it doesn't generate any moment, so it's going to be zero. So only here that this is the case we have. Now assume that we have, for example, something like that. And then part here, and we have a force applied here. We want to find the moment. What, for example, if this is the A, we want to find the moment about point A. So we want to look at that. The first thing we want to, so that's the force. We'll go ahead and we draw the line of action, and then from point A we draw the line that is perpendicular to the line of action. So that's going to be the distance about that. So if that's it's going to be F, and that's the D. And which direction is going to rotate it? Again, assume there is a rope connected from the O to the end of that force, and look at which direction is going to rotate it. So it's fixed here. It can move on the other end. So it can go. So it's going counterclockwise. So the moment is going to create here, if this is the F and this is the F, so the M is assuming counterclockwise positive FD. Now if I have that same format, but this time assume the force is applying like that, so it's applied here. This time the force applied here. I want to find the moment about point A. So to find the moment, one thing that we need to do is just go ahead and find it and draw the line of action. So the first thing first, draw the line of action. So it's going to be the line of action, and from point A, draw the line that is perpendicular to that line of action. So it's going to be D. So that's the normal distance, and which direction is going to rotate it. So it's going to unconnect the rope from here to here and see which direction is going. So it's going to rotate the rope there. So it's going to rotate it in the counterclockwise format. So it's going to be negative, it's going to be positive. So the M is going to be F, and if this is FD, the positive format is going to create. Now assume that I have again the same thing, point A, and this time assume instead of what I have a force that applied like that. So again, in 2D, anytime your force is not parallel to X and Y axis, just find the X and Y component of your forces. So here I want to say that if this is the F, the X component is going to be, that's going to be the Fx, and that's going to be the Fy. Now I can find the moment for this force. So I start for the Fx. The moment for Fx, extend the line of action, and then draw the line that is perpendicular to the line of action, and assume that's a D1. So that's a which direction is going to rotate it. Assume there's a rope connected from A to end of Fx, and rotated that rope counterclockwise. So if that is fixed at A, so M is going to be, if I assume the counterclockwise positive, and again one more time, we just assume this is the positive. You can consider the clockwise positive. Well, here we can assume the counterclockwise positive. So the M is because Fx rotate counterclockwise respect to the O, respect to that point O, about point O, is going to be positive Fx d1. And then I go to find the moment for Fy. So I will extend the line of action, and if this is a line of, I find the normal distance. I draw the line from the point to the line of action, and assume this is the D2. And which direction to rotate? I connect the line from A to F2, and if you look at that, if it's fixed at A and can rotate here, it's going to be rotated downward or clockwise. So it's going to be negative. So it's going to be negative Fy, and then times D2. And any other problem you are given, you can do the same method to find the distance. So remember, always whenever you have a force, draw the line of action, and from the point you want to calculate the moment about that point, draw the line normal to the line of action, and that is your distance. Sometimes your force is in a location that, for example, here you can draw the lines right to the force. Sometimes it's not, like here. Sometimes it's not. Sometimes away, so you have to draw the line of action. So always draw the line of action. Draw the from the point to that line, and draw the line that is start from the point you calculate in the moment about that point to the line of action, and make sure it's perpendicular to the line of action, and that's going to be your distance. And for the rotation, assume there's a rope connected from the point to the force, and assume at the point is fixed and see which direction the force is going to rotate that rope. If it's rotating that rope counterclockwise, so the moment is counterclockwise. If rotating in clockwise, so your moment is going to be clockwise. So depend on the direction you chose to be positive. So you can consider the moment to be positive, negative, positive, negative. So that's how we can find the moment arm and the direction of rotation for the moment.